I'm going to show you, that's right. So, I'm very happy, first of all, with how you've gone about this. I think you've done very well. We'll start with Bob again. So, Bob survived his last fall, but unfortunately fell from his medical helicopter 250 metres above the ground. How long did he take to fall? How long did he fall for? So, we went through before and identify what we know. So the first step was in the black here, and it was D equals 250 as we found from here. But that was the only information we really got out of the question numerically. The rest we had to think about. So when you fall off something, your initial velocity is always 0. Because the moment you start falling, you have no velocity. Very quickly into your fall, you gain velocity. And we know the acceleration due to gravity is 10. Or 9.8, depending on how precise. We then identify if we've got D, V, I, A and T. That's the equation we've got to be using. Let's have a crack here. So, D equals VIT plus half, I won't do half, AT squared over 2. I then sub my known variables in. My known variables are 250 equals 0t plus 10t squared over 2. Now something a lot of us struggle with. 0 times 1. 0 times 2. 0 times 4,347,000,000. 0 times t. So we can put a line through that t. If you can't put a line through that t, you need to use quadratics, a method we're not very familiar with. So it's unlikely you're going to be asked to find t unless vi is equal to 0 with those sorts of problems. Not in year 10. So we get 250 equals 10t squared over 2. I then rearrange to get t by itself by multiplying both sides by 2 first. That causes those to cancel. 250 times 2 is 500 equals 10t squared. Rearrange that by reverse BIDMAS as I divide by 10 first. T squared equals 50, and we square root 50. T equals plus or minus 7.07 seconds. Can time be negative? So it's really just 7.07 seconds. You could have rounded it up, I don't know. I didn't put it in my calculator. So, the skills involved with this, year 10. There's a few steps, okay, to this problem. The first is being able to interpret the information out of this wordy paragraph with lots of useless information, identifying, well, what do I actually know? That's the first step. Very difficult.
How do you know that the acceleration is 10 meters squared?
Because I know that we're doing this on Earth.
Oh.
And the gravity on Earth causes things to fall at 10 metres per second squared.
Right.
If it was on the moon, it'd be different.
Yeah.
But most people don't get medevaced off the moon. So we pretty safely can assume it's on Earth.
What was the later of the festival that crashed, cut out on Mars? It'll be getting there.
That's right. From there it's about identifying what am I looking for and then picking the correct equation. So skill 1, deconstructing the problem. Skill 2, identifying what I'm looking for and what equation will get me that. And then skill 3, rearranging. Skill 1 and skill 3, we should be relatively familiar with. We've done these things before. You interpret word problems in maths. You rearrange in maths. We've rearranged in physics. Now, in saying that, I also appreciate that it is difficult. But if you can break down each one of these problems or identify where you're getting stuck. So if you did this part very effectively, if you got your variables down, but couldn't think of the equation, that's fine. It's the first day we've seen them. But you need to make sure that by the end of week 6, say, you know these equations and you're comfortable putting them in. If you struggle with your rearranging, you need to go back and practice on page 2 of our workbook, or go back to basics, reverse bid mass, opposite operations, and just get really comfortable cancelling out and rearranging equations. From what I saw, most of us struggle with this part. Most of us got to a point where we had the values in, but we didn't quite get the T correct. Keep chipping away. Have a go at question 4 over there.